Now I take the chapter 6 of class 11th, the Newton's laws of motion. So before that, the Newton's laws of motion, that is better to understand what is the meaning of inertia. Actually, the Newton's law starts just from the study of the inertia. So we take the inertia. Inertia. The word inertia has been taken from a Greek word iners, which means idle. It means that the body remains to idle at in the position whatever to this one, either this is at rest or this is moving, then it does not want to change its position of rest or the motion or the direction of the motion. Because of that, this is given the name, the inertia, the Greek word. It is one of the primary presentation of mass which is quantitative property of a physical system. Physical system is what? The body, the object, which is either at rest or in the uniform motion. So this inertia is mainly related with the mass of the body. Inertia is the resistance of any physical object to any change in its velocity or direction of velocity. It is the property of an object which opposes any change in its position of rest or motion when the force acts upon it. When the force acts on it. Until there is no force, there is no change in the position of the object. If the force is applied, then there is a change in the position of rest or position of motion, or the change in the direction of motion. The inertia of an object depends upon its mass. Larger the mass, larger the inertia. So this mass is called the inertial mass. It is called inertial mass of the object. So inertial mass means inertial mass equal to the matter contained in the body. Contained in the object. Contained in the object. Larger the mass, larger the mass, larger inertia. Larger inertia. So this is why we have to apply more force for the body which have the very high, which have the very large value of mass, and this mass is expressed in kilograms or the grams. It is now we can take the unit of inertial mass. Unit of inertial mass, that is kilogram in MKS, gram in CGS, and pound in FPS. Pound in FPS. So when the body moves not in the field of the gravitation of the earth, then this is called the inertial mass. But when the body moves in the gravitational field of the earth, then this mass is called the gravitational mass. Both the masses, whether this is the gravitational mass or the inertial mass, both are equal. There is no difference in the inertial mass and that of the gravitational mass. The name the inertial and that of the gravitational is given on the basis that whether the force is applied in such a way that the gravitational force is not affecting its mass, then this is called the inertial mass. If the mass is affected by the gravity of the earth, then this is called the gravitational mass. So both the masses have the same unit and they are having the same meaning. Principle of inertia. It is one of the fundamental principles of classical physics. Because initially what we see that the mass of the body is how much heavy to this one, then that is the first we look the inertia of the body. We can experience this mass, whether this is heavy or small, just by lifting to the body. So according to this, according to it, an object will continue moving at its constant velocity until some force causes its velocity or direction to change. This is the principle of inertia. An object will continue moving at its constant velocity until some force causes its velocity or direction to change. यानी जब तक वस्तु पर कोई ऐसा बल न लगाया जाए जो इसकी वेलोसिटी को बदले या फिर इसकी डायरेक्शन को बदले, तब तक the object will remain as such. So the position of the object does not change until and unless the force is applied on the body. So just at the time of Newton, there was other scientists like Aristotle, etc., who always said that there is some agent that keeps the body to move continuously at the same speed or the same velocity in the same direction, but Newton said that this is not so. No force is required. If the body is moving, it will continue to move. If it is at rest, it will remain at rest until or unless some force is applied. So this gives the concept of the force. The first law of the Newton gives the concept of the force. So now we take the Newton's first law of motion. Now one thing you all remember, Newton gave three laws of motion. First, second and third. First is to this one, that the inertia, that is based on the principle of inertia. Second, that is the force, and third, the action and reaction. Actually, what that some of the students are confused because they have also studied the equation of motion. So they understand that the equation of motion are the Newton's laws of motion. This is not so. Equation of motion equal to V equal to U plus at, S equal to ut plus half at square, V square equal to U square plus 2as. These are the equations of motion, not the laws of motion. Laws of motion are quite different from these equations. So this should no confusion in the mind that equation of motion are different from the Newton's laws of motion. Now I am taking the Newton's first law of motion. Newton's first law of motion. Now from all these things there are this inertia. The Newton draw a conclusion that is based upon the principle of inertia. So that is called the Newton's first law of motion. It is based on principle of inertia. According to Newton, the object at rest will remain at rest and the object in motion will remain moving with constant velocity, in the same direction. In the same direction until and unless some external force. External force is applied to change its position of rest or motion. This is what the Newton's first law of motion. The object at rest will remain at rest, and the object in motion will remain moving with constant velocity in the same direction until and unless some external force is applied to change its position of rest or motion. There are so many examples of this one. It is called Newton's first law of motion. Examples. I am giving you so many examples, but you take just some prominent examples. Number one, suppose there is a bus and the passengers are inside the bus, and this is at rest. And now the bus starts to move suddenly. Then you could have seen that the passengers get a jerk on the back side, because initially they were at rest. So after the motion they have want to remain at rest. Because of that, to attain the new direction or to attain the position of the motion, they have to oppose the inertia of motion. So on this basis, we can say that this is opposed, the change in state. Because of that, the passengers inside the bus are getting jerk on the backside when the stop or the bus at rest suddenly starts to move. When a bus at rest suddenly it starts to move, the passengers inside the bus get a jerk on backside. This is due to the inertia of rest. It is due to inertia of. Similarly, suppose there is a horse and the rider is on the horse, and the horse at rest just starts to move. Then the rider gets a jerk on the backside. So that is also the example of the position of the rest, the inertia of rest. if a moving bus stops suddenly, the passengers inside the bus experience a forward jerk. तो अगर चलती हुई बस है और अचानक रुक जाती है तो हमें पीछे की तरफ झटका लगता है, because we are moving in the forward direction, so we want to move in the forward direction. So just to obtain the new position, we have to oppose the change in the motion. So this is the example of the inertia of motion. It is due to inertia of motion. Similarly, if a moving horse stops suddenly, the rider falls down. This is due to the inertia of motion, because we were moving along with the horse, so when the horse stops, that is okay. But our upper portion, which is in air or which is not in touch with the horse, that does not stop. So it has to bend in the forward direction. Because of that, we feel a jerk in the forward direction. Now third, let a moving car takes a circular turn. The passengers inside the car experience an outward pull away from the center, away from the center of circular path. विजय सपोज करो कि एक कार है और ये ऐसे मूव कर रही है। अब ये कार ऐसे चलती हुई यूं टर्न लेती है टुवर्ड्स द राइट, तो इसमें जो पैसेंजर्स बैठे होंगे दे हैव टू एक्सपीरियंस ए पुल, आउटवर्ड पुल अवे फ्रॉम द सेंटर ऑफ द, तो ये सर्कुलर पाथ है, ये इसका सेंटर है, तो इधर की तरफ टुवर्ड्स लेफ्ट दे विल एक्सपीरियंस ए पुल and they will find that somebody is pulling us away from the circular path. If suppose the body take a turn towards the left, then they have to experience a pull on the right side. So because of that, there is a change in direction. This is due to the inertia of direction. It is due to inertia of direction. Inertia of direction. So now we can have three kinds of inertia: inertia of rest, inertia of motion, and inertia of direction. If the force is not applied or there is no change, then the body will continue to move or continue will at the rest until and unless the force is applied on it. So this is the Newton's first law of motion. Now I take the linear momentum. Linear momentum. Whenever we say momentum, then it is always related with the velocity. The product of mass and that of the velocity is called the linear momentum. The product of mass and linear velocity is called momentum, denoted by P. So what we have? This P is equal to mass into velocity. So this P is equal to m into v. P is a vector quantity. Now here you can see that this is the scalar quantity, the mass, velocity is a scalar vector quantity, so this P is a vector quantity. P is a quantity, vector quantity. इसकी डायरेक्शन क्या होगी? The direction of P is in the direction of motion. The direction of P is in direction of velocity v. It means क्या है? P और V दोनों पैरेलल होते हैं. तो अगर कोई ऑब्जेक्ट है, this is now suppose an object, and this is moving with the velocity v, then its P will be also in this direction. So what we have? That this P is parallel to V. इनके बीच में जो एंगल होता है, that is of 0 degree. So P और V दोनों इसके पैरेलल होते हैं. So whenever we are having this kind of product, then this is termed as the linear momentum, because velocity is the linear one. So this is called the linear momentum. When the body is rotating, then it is the angular velocity, and in that case we take the angular momentum. So that is different one that I will tell you when you will study about the rigid motion of the bodies. The rotational motion of the rigid bodies. Now you can say that the unit of this one, this is now your kilogram, this is now meter per second, so kilogram meter per second, kilogram meter per second in MKS system. This is now your gram centimeter per second in CGS system, and this is now your pound foot per second in FPS system. Now, in addition to this one, we are adding one more unit to this one, that is now the Newton second. Newton second. This is one more unit. One more unit. Newton and S second, Newton second. And now you can see that the change in P may be due to the change in momentum and the change in velocity. So either of them is changed or both of them are changed, then there will be a change in the momentum. So momentum is affected by both the quantities, the mass and the velocity. Thus, linear momentum depends upon mass and linear velocity. So this is about the momentum. Now after this momentum we come to a point which is very important, that is the Newton's second law of motion, that is related with this one. So before that I will like to tell you what about the force. In the Newton's first law of motion, we have a concept of the force. What we said, that the state of the body does not change until and unless some force is applied on it. It means that force is an external agent which may change the position of the object or may not change the position of the object. If the objects are such that the position can be easily changed, then it can be done. But if the object is very heavy, then you cannot change the position of the object. Suppose I say that just you push the ball, push this ball, you cannot push it. You are applying the force, but you are not able to push this vertical wall. It means what? That your force is unable to to give any change in the position of the object. Force. The external agent which either changes the position of the object or may change the position of the object is called force. So force ऐसा भी हो सकता है कि चेंज कर दे, ऐसा भी हो सकता है कि चेंज नहीं भी कर पाए. We just try to change the position, but this is not necessary that you could have any change in the position of the object. The forces are of different kinds. That I take number one. Contact force. Contact force means that when the force is applied on the body by a means of an object which are in touch with the body. Suppose just you push or pull the gate or window, just you stretch a wire, stretch a spring, that is the contact force, because your hands are coming in contact with the body. When force is in contact of the body, it is called contact force. For example, pulling or pushing an object opening and closing of gate and window, stretching of wire, stretching of a wire, and just compression and expansion of a spring तो इसमें क्या होता है that suppose you are having this is now suppose your wire and this you apply the force on this side, so this will get stressed, then this will be like this one. This is a wire. This you are applying the force. So this length has been increased. Length will increase. Similarly, suppose you are having this spring. This is now a spring. And just to elongate it or just to expand it, then what will happen? This will be in this way. This is now expanded, so this is now force F. This is now also the force F. Then this is being expanded. This is the expansion of the spring. Expansion of the spring. So what we have? We can have at so many examples when the force is always in contact with the body. Similarly, if you have other so many examples, these are called the contact forces. This is the force applied by the body of the human, or when the two bodies collide with each other, then even they are applying the force with one another. Colliding bodies. Collision of bodies. इसमें भी क्या होता है? That these are the bodies. This is moving like this one. This is now suppose A. This is now suppose B, and then they collide. What happened? Then suppose this is body A. This is body B. And then they apply the force, mutual force. So this body is applying the force on this one. In this way, this is now force. This is now body A. This is now body B. Then force on body B. This is FBA. Force on body A. FAB. So both the bodies apply the mutual force. So because of this, they change the direction of motion and the magnitude of velocity also. So this is the force, the contact force. This is about the contact force. Now forces also, similarly your frictional force, viscous force, they are also the example of this contact force. Frictional force. Frictional force. That the viscous force. These are the examples of the force in contact. But forces also act at some distance when the objects are not in contact. So now second number is distance. The force working at some distance. These forces are not visible to us, but we can experience them. These forces at some distance from each other. We can have so many examples. The gravitational force, the electromagnetic force, etc. So these forces act always at a certain distance. Suppose here we are having a small sphere. This is another sphere. This is sphere A. This is now sphere B. Then this sphere is applying the force on this one. So this applies the force on this one like this. This applies like the force on this A. This is the force applied by A on B. This is the force applied by B on A. So, though they are not in contact, even the forces are acting. This is the gravitational force. This is now suppose distance R. Similarly, if you are having let its mass is m1 and this mass is m2. Similarly, suppose we are having two charges. These are the two charges. This is now charge your Q1, this is now charge Q2. These are at some distance. Then they apply a force like this. This is now distance R. This is our electrostatic force. Electrostatic force. This is gravitational force. Similarly, the magnetic force, if we are having the magnet, then you can see that the similar poles always repel each other. The dissimilar poles attract each other. So, though they are not in contact, even they exert the force, and that these forces are called the forces at distance or forces not in contact. So, force at distance we have like this one. So, these are the two kinds of the forces, force in contact and force at distance. Now I take the Newton's second law of motion. Now from here, the Newton's second law starts. Newton's second law of motion. What is Newton's second law of motion? This is related to the force. Related to the force. The time rate of change of the linear momentum is equal to the force applied on the object. Time rate of change of the linear momentum is equal to the force applied on the object. तो उसके बराबर होती है या उसके समानुपाती होती है, कैसे कहिएगा इसके अंदर? समानुपाती होने पर एक प्रोपोर्शनलिटी साइन आ जाता है, इसकी वैल्यू 1 के बराबर होती है, तो either we say like this one, then this is also correct. So if there is a change in the linear momentum, only then there is the applied force on the body, because when we apply the force, the velocity changes. So change in velocity, that is the acceleration. So that is what we have this with the help of linear momentum. So what we have? The force F is equal to delta P upon delta T. This is not so much. Delta P change in momentum in time delta T. So rate of change of momentum is how much? Delta P upon delta T. That is equal to the applied force. And this is also limit delta T tends to 0. Delta P upon delta T. Then this is equal to dP upon dt. This is equal to force F. So you can see that larger the change or quickly the change, larger is the force. Smaller the value of time, larger will be the force. So this F is equal to d upon dt m into v. Because we are assuming that mass is not changing, so we are changing only the velocity. Then we can have this m to be constant. M, this is now dv upon dt. So this is now m into a. This is equal to F. Where A is equal to dV upon dt. Linear acceleration. Linear acceleration. This is the second law of motion. So what we have that this force F equal to mass into acceleration. Mass into acceleration. Mass into acceleration. A, that is the acceleration. So we can have Now I take the units of this one. Unit of force. That is, we take the N case system or SI unit. This is now your kilogram meter per second square, kilogram meter per second square, or this is equal to the Newton. N is Newton. So what we have is 1 Newton equal to 1 kilogram meter per second square. This is in NKS or SI unit. So from here we can write the definition of 1 Newton. If an acceleration of 1 meter per second square is produced in a body of mass 1 kg, then the force will be 1 Newton. Now similarly in CGS system, this is now your gram centimeter per second, and this is also dyne, or we have this 1 dyne equal to 1 gram centimeter per second square. Now we have relation between this Newton and dyne, that is the 1 Newton is equal to 10 raised to the power 5 dyne. This is so much. Now in this is also expressed in kilonewton. This is in terms of Newton. Then we can have the kilonewton. This is equal to 1000 Newton. Kilonewton, this is now your 1 kN. This is equal to 10 raised to the power 3 Newton. This is so much. We can express it, the Newton is large one, then we can express in kilonewton, meganewton, giganewton, like that we can express. This is now LKS, this is in CGS, and then in FPS. FPS system. Now this is in pound foot per second square. Pound foot per second square, denoted by lbf. So what we have, that the value of 1 lbf equal to 1 lbf equal to 4.44 Newton. This is our relation. lbf. If we take the absolute FPS system, absolute, FPS system, then this is expressed in pounder. denoted by PDL. So 1 Newton equal to 7.2. This 1 Newton equal to 7.2 PDL. This is not so much. Now there is one more system to express the force, that is the gravitational units. Gravitational units or metric system. Metric system. Now here the force is expressed in kilogram force. Kilogram force. Shortly kgf. So what we have, this 1 kgf is equal to 9.81 Newton. This is not so much. kgf. This is either you see the metric unit or you see the gravitational unit, then this is expressed in terms of kilogram force. So now this is about the units of this force, and this is the second law of motion, Newton's second law of motion.